Let's talk about combining and modeling with transformations. So we want to know how an understanding of one function can lead to an understanding of a whole family of functions. And the key is transformations. A transformation in geometry means taking a geometric object like a graph, which is a geometric object, and manipulating and moving it, sliding it, rotating it, things like that. So here we have a function. We've got the absolute value function as an example, and we want to find out what happens when we change that function a little bit. So we have plain old absolute value of x. But what happens when we add 3? Well, keep in mind that the value of the function g of x here, g of x and f of x, these are the height of the point. So when we say f of x is absolute value of x, that's the height of the point. So the height of this point, C, was at 1. And when we add 3, that's going to take the height and add 3. So that's doing the function f of x and then adding 3. So we can hopefully see that, hey, that just changes the height, because the value of the function is the height. And that's real important there to realize that we're talking the height of the point. So it moves up 3 when we add 3. Well, what happens when we subtract 2? If we take the absolute value of x, which is f of x, and we subtract 2, well, we're going to take the height of the original point, and we're going to subtract 2. So that b value is going to go down to, that c is going to go down to a new c value. We might call it c double prime. So the height changes when we add or subtract to f of x, okay, outside. So that changes the height. Well, what happens when we add or subtract inside the function, or inside, usually the parentheses is what we talk about. Well, here's f of x again, being the absolute value of x, just as an example. And what we're going to do is we're going to change what happens inside. Well, if we do x, well, let's go with x plus 3 here first, okay? So if we take that function, that good old f of x, and we're going to take and say, let's let g of x be f of x plus 3. That means we're going to take that old absolute value, which was f of x, okay, because we said a moment ago that f of x is the absolute value of x, and we're going to put x plus 3 in place of that x. And what does that plus 3 do? Well, we can see in the graph it moves it left here. So it moves that whole thing left. And a little tricky, it seems like it should go right, but it's the opposite of what we would expect. And part of the reason is because we can ask ourselves, what number can we put in for x to make this act like 0, to make this whole thing become 0? Well, the number is -3. So if you put -3 in here, this whole thing becomes 0. So -3, right here we have an x value of -3, acts like 0 did in the original function. And so everything gets bumped up 3. So this point mirrors the point that is 3 to the right of it. This point here mirrors the point on the blue one that's 3 to the right. Everything mirrors a point that's 3 to the right. So that's why adding moves left. And subtracting, as you can see here, subtracting is going to move it right. So x minus 2, well, that's because this point here is going to mirror a point that was to the left 2. Okay, so it's going to copy that one in place of it. And so subtracting moves right, adding moves left. And so it's opposite from what it seems. Adding inside the parentheses, or adding inside the function, moves it left, and it moves it right if we subtract, or if we say we add a negative number. So we saw in the last one there that if we add or subtract, it slides it left or right. Well, what happens if we multiply by some number, call it a? We take our function, we multiply by some number. Well, let's take a little more complicated function. F of x equals x to the fifth minus x squared. And we're going to choose that because it's going to show us some interesting things. So that's the blue curve here. That's what it looks like. Okay? And we want to see what happens when we take the function and we multiply that whole thing by 6, for example. Well, remember that f of x is a height. So we're taking 6 times the whole thing, x to the fifth minus x squared. So what that means is we're going to figure out the height of f of x, because this here is just f of x. All right, we're going to figure out the height, and we're going to multiply it by 6. Well, if the height is positive, like in this blue function here, we have a height of 1, okay? And we're going to stretch that 6 times higher, and it's going to go way off the charts. So this green curve will come up and pass through that 6 there. If we look at this point here, this has a height of, maybe negative 0.3, it looks like. Okay, well, f of x is negative 0.3 there, but when we put that same x value, whatever this x value is, it's going to multiply it by 6, and it's going to give us a height of negative 0.3 times 6, which is negative 1.8. And yeah, that looks like it's about 1.8 right there. It's not quite down to negative 2. So it's stretched away from the x-axis 6 times as far. Now, if it's an x-intercept, the blue point is stretched 6 times farther, but the blue point is 0, so 6 times 0 is 0. And so each of these points here, let's zoom in a little bit here, okay? If we take this distance right here, whatever distance that is, well, this distance down to the point right below it is going to be 6 times as far. Okay? So we're stretching it 6 times. So multiplying outside stretches it vertically. So if a is greater than 1, it stretches the graph vertically. Now, if a is less than 1, if it's something like a half, well, if we had h of x equals 1/2 of f of x, that means all the points would be half as tall. So we would take this graph and it would kind of flatten it out a little bit. Okay, it would be not as far. It would be less steep. So if a is less than 1, it will make it less steep. So that a value, if it's less than 1 or greater than 0, it will stretch it. Shrink it. Less than 1, it will shrink the graph vertically. It'll be less steep. So the last question we have to ask ourselves is, what if it's negative? What if that a value that we're multiplying by is negative? Well, if we put a negative out here, it's going to take that whole graph, x to the fifth minus x squared. Whatever point f of x was, it's going to make it negative. It's going to change it vertically. Because remember, f of x is the height. So if the height was about negative 0.3, when we put negative 0.3 in for f of x, we're going to change it to positive 0.3. So g of x will have a positive value. So it reflects across the x-axis. Okay, so this green one here is negative f of x. The blue one is positive f of x. So making a negative flips the graph vertically, upside down. So we saw that if we multiply outside the function, that just moves it vertically. Because remember, the value of the function is the height, and so if we multiply that height by a number, it's going to make a vertical change. It's changing the height. But now if we mess with the inside, changing the inside is going to be a horizontal, just like when we added or subtracted from the inside. So let's take our function, f of x equals x to the fifth minus x squared. A little different function, a little more complicated, but it's going to show us nicely what's going on. So let's take a new function, g of x, and let's call that f of 6x. And just to kind of get a better handle on what that means we're going to take 6x and we're going to put that in place of x in this function up here. So it's going to be, well, our function is x to the fifth minus x squared. And so we have 6x to the fifth and 6x squared. Oh boy. So this is going to be a huge number. We've got 6 to the fifth and x to the fifth. Remember that 5 applies to both of those things. And 6 squared, x squared. And this is a huge number, 7,776 x to the fifth. And minus 36x squared, okay? So there's our g of x. That's really what's going on. So when we say g of x is f of 6x, well, it just changes the function like this. Well, so what does that happen? What does that do when we multiply x by 6 first? Well, it's going to change the horizontal. Okay, it's going to make 1/6. When I put 1/6 in here, it acts like 1 because 1/6 times 6 is 1. So in my new function, the green one, 1/6 acts like 1 did over there. Okay, so likewise, all of these distances here are going to be 1/6 of the distance it was. It's going to shrink it horizontally, okay? So everything's getting shrunk. So this distance right here is 1/6 of the whole distance. Or if we said this, if this distance here is x, then this distance to the green line would be 1/6 times as big. Okay, so when we multiply, you can see by this green curve, when we multiply by a number larger than 1, it's going to shrink it towards the y-axis. So it has this horizontal shrink. Now, if we did the opposite, if we said h of x was 1/2, let's say, of x, or more specifically, we need to say f of 1/2. F of 1/2 x. Well, what this is going to do is it's going to stretch it, and it will take something like this. It'll be twice as far. So this curve's going to stretch over there instead of crossing there. So it's going to go down like this, and it's going to stretch. Something like that. So that red curve, if we had 1/2 x, so that's horizontal stretch because the distance from the y-axis will be twice as far. So if we multiply by something that's less than 1 but greater than 0, it's going to have horizontal stretch, stretching away from the y-axis. Now, what about if we make it a negative? Well, if we make it a negative, it's going to flip it in a little different way. So here's our function again, and let's now say g of x is f of negative x. That means we're going to put negative x in place of each of these. And what that's going to do in our green function here, it's going to make, when x is 1, right here in the green function, well, if you put negative 1, if you put positive 1 here, that negative makes it act like positive 1 did. Sorry, I said that backwards. Let me try again. So if you put positive 1 in here, it makes it act like negative 1 did in the last one. All right? So it switches roles, kind of. And when you put negative 1 into the green function here, it says, well, negative 1 is positive 1. It right away becomes positive 1, and it gets its height from where positive 1 was, which is the x-intercept. So the negative inside flips it horizontally. So a negative value for b flips it horizontally. All right, and let's look at one example here. So here we have a function g of x that we want to write as a transformation of f of x. So these are both parabolas, and so we will usually be told that this f of x is our x squared. So we're transforming plain old x squared, one of our basic functions. So we notice a couple things. We notice that these points, specifically the vertex, is going left 5 and up 1. So we want to describe g of x. And we can do this a couple ways. We're going to move it left 5. Well, that is going to be a change inside. We're going to add or subtract. But remember, left and right is opposite from what it seems. So this has moved left. It seems like it should be negative, but that's going to be adding 5. Because if you put negative 5 in here, it'll be 0. All right, so we adding 5. That moves it left, but we got to move up 1. So we're going to put a plus 1 because adding to the whole changes the height. So plus 1 there, that gets us up there. And now we notice that this curve is not quite the same. If we look over here, we're going right 1 and up 1 from the vertex from point B to point C. Well, here we're going right 1 and up 2. So it's going up twice as fast. Here we go over 2 and up 4. Well, if we go over 2 here, it's off the charts, but it would be up at 8. So it's going up twice as fast. So how do we make this stretch vertically? We multiply outside the parentheses to make it stretch vertically. Remember, if we multiply inside, that stretches horizontally. So there's our function there in terms of that quadratic. If we want to be more general, we could say g of x is 2 times f of x plus 5 plus 1. That would be the general description of what's happened there. All right, so that's how we do it. So go transform those functions.